Welcome to predicate logic. So we started this chapter by talking about propositional logic, and now we're going to get into predicate logic. Now, propositional logic, I said, was the simpler and more limiting thing. So if I wanted to look at this claim in propositional logic, and let's say this claim is that every state in the US has a governor. Well, to examine that claim, we really have to look at 50 different claims, right? We have to look at 50 different propositions. Maybe our first proposition would be that Alabama has a governor, and maybe that'll be true or false. Our second proposition would be Alaska has a governor. Our third proposition would be Arizona has a governor, and we'd have to keep on going on and on and on, and then look at, what is G2 and G1 and all the way down to G50. And that'll either be true or false. And that's how we could look at that claim in propositional logic. But it's a little annoying to have to create and design 50 different propositions for this. It sure would be nice if, there was some kind of rule that we could use to kind of introduce one type of proposition and then apply it to all the 50 different states. Well, some kind of rule that could be applied to something. Well, in terms of math and computer science and logic, rules have another name. Functions. Everyone's favorite F word. I'm sure every time you think of functions, you think of fun, another F word. Okay? So that's what predicate logic is all about. So predicates are functions. Woohoo! All right. And specifically what we're going to be talking about is first order predicate logic. So first order predicate logic is going to be basically functions applied to the domain of discourse. In this case, our domain of discourse, omega, right, is going to be the set of all states. All right. Now, when you start getting into second order predicate logic, that's when you start talking about functions of relations. So the inputs of our functions are just going to be things like states, things from our domain of the discourse, just kind of things. Second order predicate logic would get into functions that work on relations, which does get a lot more complicated, but very cool. But we are only talking about first order predicate logic in this class, okay? So we could define some kind of function as the following. Let's call our function hasGov. I don't know why my S is so big. That should be a lowercase s. I apologize. All right, hasGov. And that function applies to x, where this is just a proposition that x is a state with a governor. So you can, very quickly see, right, that G1, I have an email. G1 is the same thing as saying gov of Alaska. These are equivalent, right? If Alaska has a governor, then yeah, Alaska has a governor. Alaska is a state that has a governor, I guess, to be really, really precise about this. So you get into some interesting things like this, and this is predicate logic. You can do some more stuff with it. All right, let's close Outlook for now, as exciting as emails during math videos would be. And let's talk about this kind of function a little bit more. So again, another way of thinking about this is a proposition. So the input is something from our domain of discourse, whatever that might be, and the output is a proposition. How can we write that more formally? We can say, right, hasGov is a relation. Maybe it's a function. Maybe it's a relation. It doesn't really matter here. We can write it the same way. That has an input from our domain of discourse. That's our domain. What's our codomain? And again, it doesn't necessarily have to be the range, because maybe we have a tautology. Maybe it's always true. So here, P is going to be our set of all propositions. And remember, logic and meaning don't really have any place here. We're really mostly caring about true or false. So this is really like a method in programming, a method that takes in some input and just returns a Boolean value. Okay, it's either true or false. So for example, right, has gov, I made a big S again. Has gov of, Alaska. What's Arkansas? I think this is Alaska. I don't really know. Maybe Arkansas is something weird, right? Alaska is a state, has a governor. This is true. Okay, that's its input. That's its output. And then we can do a bunch of things with this as well, right? We could say, what's has gov of Washington, XOR has gov of Arizona. Well, this is true. This is true as well. XOR is only true when exactly one of them are true. So this is false. So all the stuff that we talked about earlier with our logical operators still applies. It's just a different way of constructing these propositions. We could even do other things, like we could say has gov of mayonnaise. Hopefully that's how you spell it. How do we evaluate that? This is the proposition that X is a state with a governor. Is mayonnaise a state with a governor? Not any state I've heard of. So that's going to be 0 here. So, it's important to wonder, what is your domain of discourse? It really kind of depends. It doesn't matter too much for this sort of thing. Okay. So that's kind of the introduction to predicate logic. We can do some examples if you want. We'll get into more of this in the future videos as well. But just kind of one more thing I think I want to clarify is that these functions can have multiple inputs, right? So you could have something like in city of. Okay, let's say this is a function with 2 inputs, and it's true if the first thing is in the city of the second thing. So for example, in city of SPSCC, comma Olympia, is that going to be true or false? Well, it's true. SPSCC is in Olympia. It's a little weird because it's kind of it looks like it's in Tumwater, but they kind of just cut out a little hole across the freeway. It is technically in Olympia. Correct me if I'm wrong, but I remember looking this up and it seemed a little weird. You could do this with other things, right? In city of, let's say Jason, comma, Pismo. It's a beach my parents and I went to when I was growing up. Am I in Pismo right now? Nope, I'm not at the beach. I am in Lacey right now on a nice, cold, sunny day, stuck inside trying to get ahead of work. Anyway, it's a fun time because I love predicate logic, but that's where I am. And of course, you could do any kind of logical operator you wanted with this. How would we define this relation? Maybe it's a function. What's its domain and what's its codomain? Well, the domain's there's 2 parts of the domain, right? There's 2 inputs. So the domain is really going to be a Cartesian product of 2 different domains of discourse. The first domain of discourse could be like things, people, nouns, people, places, things, whatever. And the second part of the domain is going to be all the cities, all the possible cities. And again, it's going to the set of all propositions at the end. Where again, when we're thinking about this from a binary standpoint, right, this is really just a set of either 0 or 1. Yeah, that's what we got here. And you could have these functions, you could have these predicates of, however many inputs you want. And they're going to be true or false. They return a Boolean value. And we'll talk more about this in future videos, but I think that's all the things I wanted to introduce in this one. Let me know if you have any questions and enjoy the rest of your day.